Hello everyone, this is Vaseem from Edureka and I welcome you all to this session in which I'm going to talk about Python programming. Now as a beginner you might face a little difficulties into understanding how you can begin Python programming and what kind of concept you should start with. Tell us in the comment section guys if you are new to Python programming and what kind of tutorial you're looking for so that we can assist you. So let's take a look at the agenda for this session guys. I'm going to start with a basic overview and introduction to basic concepts like variables, the operators, and the data types in Python. And after that, we will move on to rather complex concepts like functions, loops, and conditional statements. Moving further, we will learn about concepts like iterators, generators, and decorators. And then we will discuss multi-threading, exception handling, and file handling. And finally, to sum up this session, I will show you a couple of programs to give you a clear picture of how Python programming can be used to write programs. And I hope you are clear with the agenda, guys. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. If you're looking for a Python certification program, the link is given in the description box below. You can go and check it out there. So now without any further ado, let's begin our session. So first of all, let me just give you a brief overview about what exactly is Python and how we use it and how it has come into existence. So Python programming language is one of the most popular language in 2020. Much of the popularity has been through the data science application that it comes with, the implementations using machine learning and artificial intelligence. It was founded in late 1980s by Guido von Rossum, and Python is a high-level interpreted language which can be used for both procedural and object-oriented programming language. Now, there are a few things that we have to know about Python, which is Python is very easy to learn, guys. It is as easy as writing, a simple code in English language, guys. It is that easy. It comes with a lot of library support, which means that for every task that you can imagine, there might be a Python already has a library for it that you can use. Also, we have our Edureka community. If you have any problems, you can just post the comments over there, and we have SMEs that help you with that particular query. So I just want to talk about how Python has so many applications. Python can be used for web development. It comes with web framework, both full stack and micro frameworks like Django and Flask. So Python is a very good choice when it comes to web development, which can be used for making both lightweight web applications and full stack web applications with API integration and database integration as well. That we can do both in Flask and Django as well. All right, so one of the applications is data science, which has contributed a lot to the popularity of Python, what it has become today. It comes with immense library support. For example, we have NumPy, there is Pandas library, there is a Matplotlib, Seaborn library, and there are libraries for machine learning like scikit-learn. There is TensorFlow, and we have PyTorch. So all these libraries come together into giving you these easier implementations for tasks that were not possible a decade from now. You had to put a lot of effort into immense line of codes, which can be done by just a few line of codes today using Python. So that is why it has become a lot of popular nowadays among the developers. Also, Python can be used for other applications like you can make GI applications using tkinter. You can draw with turtle. There is opencv, which can be used for computer vision. Then there is NLTK for natural language processing. So you name it and you have already got it with Python, guys. Python is one of the most desirable language for developers as well. But since it is very easy to learn, it is quite important to understand why you are learning Python and what is going to be your objective or your goal when you finish learning Python. Because after you finish the basic concepts like variables and all these concepts that we are going to discuss in this session, you have to know, or you have to be sure which domain you're going to go for. You could go for data science, you could go for machine learning, you'd go for artificial intelligence, you could go for web development, you could go for software development. But you have to be clear in your goal or in your structured learning path. So this is why you are learning Python, because since it's very easy to learn, most of the people are learning Python. But one thing that most of the people also miss is a structured learning path. So whenever you're starting out as a beginner into learning Python, you have to make sure that you have already got the objective clear in your mind, and then you can begin learning Python. It's very easy, guys. So let's just begin with first thing. We're going to start with the basics. So first we're going to talk about the variables, guys. And variables are nothing but exactly the same as any other programming language. If you have worked on any programming language like Java or C++, So a variable basically is storing a value that may change in the future, which the name also suggests, guys. So let's try to understand variable using an example. Let's say, so I have certain commodity, let's say, which keeps changing because for that, let's put the commodity as a bunch of apples I have at home. So I'm going to use a variable, let's say apple, and it is basically storing the values of how many apples I have. So after each step, we will take these steps as the steps of the execution of a program similar. So let's say in 1 hour, I'm eating one apple and I have 24, 25 apples. So the variable that I have put the value in is kept changing for 24 hours. But it's not necessarily true that I will be only eating the apples. I might add value to that variable as well. So this is just a simple example, guys. And I'm just storing a particular value inside a variable. Not necessarily the Apple one, we can think of a little complex one as well. So let's say a bank account, like how money keeps coming in and coming out. But account balance can be that variable which stores the value of how much money you have in your account. That is also one variable, guys. So let's take it up to Jupyter Notebook, guys, and we will see how we can work with variables in Python. So I'm going to show you how you can declare a variable and discuss a few naming conventions. Rename this. And just to be clear, guys, this is beginner's tutorial. So if you already know how these basic concepts work, you can move further in the video where I have discussed exception handling, and there are file handling concepts and multi-threading classes and objects as well. All right, so the very first thing, let's take a variable. Okay, we are going to use variable only. So this is my variable. I'm using this is equal to sign. We're going to discuss this in about a minute, guys. So I'm giving it some value, and I'm using these inverted commas also, so I'll talk about this as well. So this is how simply I have given the variable name. Now I can use a method. This is a predefined print method that I can use to return the value. So this is how we get the value from the variable. We are using this print method. Method is basically a function. I will discuss this as well. And so let's talk about naming convention. So naming conventions are nothing but certain rules that you have to follow while declaring a variable. So these are some of the conventions that you should follow to write clean code. Right. So the very first rule or convention that you have to follow is the variable name cannot start with a number. Right. So it can only start with a character and underscore letter. So I'll just show you guys. So let's say if I want to write it like this and give it some value, I have a syntax error which says invalid syntax because this is written in the naming convention. You cannot declare a variable like this. All right, so let's try with an underscore and we're good to go. Double underscore, we are also good to go. Any other symbol? All right, so we will have a syntax error. All right, guys, after this, the second convention is variables in Python are case sensitive, which means is if I have a variable like this, which is starting from an uppercase letter V, and we have this variable which starts from a lowercase letter v, what happens is these are two different variables, guys. All right, so I'll just change this value so that we have a clear picture. So I have variable which is giving me the output some value, and now if I write uppercase letter V, I have different variable, guys. So which means variables in Python are case sensitive. So this also you should always remember, because while declaring a variable, sometimes you might miss these certain points while declaring a variable. Let's say you start with uppercase letter, and then again when you're calling that variable, you might not remember that you have basically declared the variable with a uppercase letter or lowercase letters. That you should always keep in mind while writing the code. And after that, there is one more convention, which is they can only contain alphanumeric characters and underscores. All right, so we have variable. If I write it as this, it's good. If I write it as this, it's good. We have a syntax error, guys. So alphanumeric characters only we can use. And after that, there is also one more rule which says no special characters are allowed. So this is all about variables, guys, and I've told you about the naming conventions as well. So now what we'll do here is we will talk about operators in Python, guys. And so operators in Python are used in order to perform a task between variables or any two values, or it could be one value as well. So depending on the operation, that the the output will vary, and depending on the operation also, we are going to use specific operators. There are different types of operators in Python that we have. So let's talk about those operators, guys. First of all, we have assignment operators, which is basically used to assign some value, just giving an assignment to any variable or any value. So when I say variable is equal to some value, I'm actually using an assignment operator, guys. which is basically because I'm using this particular operator, assign a value to a variable. So that is how it works, the assignment operators. Let's say I'm taking a variable value 1 over here. So if I write variable is equal to variable plus 1, this I think most of you must be aware if you have come from programming background. So I can write this particular sentence because variable will now become 2. So instead of using this, I can write it as plus is equal to, and it will give us the same value as the whole program. It will give us the value 3. Now if I run it again, and this will become 4. So similarly, this is for addition, for subtraction, for division, for multiplication, for floor division, and all those operators that we can use. So alright guys, so the next in line is the arithmetic operators. So the very first one is, get any operations running, arithmetic operations. So the first one is very easy, guys. We can write 10 addition, two numbers, and a is equal to 12. And instead of addition, we can do subtraction, and instead of subtraction, we can do division. So just look at the difference, guys. Now when I do the floor division, we do not have a float value. So that is the difference between division and floor division, and we can multiply, do the multiplication using asterisk, and if I use double asterisk, it will give me the exponentiation of 10 to the power 2. And yeah, these are all the arithmetic operations for now as a beginner, these aware of. After that, there are operators like comparison operators, which are basically used to compare two values. And then we have logical and, or, and not. So these I will discuss when I am talking about the conditional statements, because these two operators are basically used there only if we have to establish a point we are comparing to the program. Okay, so we'll discuss that, these two operators there. And then we have membership and identity operators also, which are used to check if the object is same for identity operator, and the membership operators are basically used to check if particular data type is actually present in an object or not, or the object is present in another object or not. That is how it works. And bitwise operator is again same. We have bitwise and, or, and not. Which, so talking about the bitwise and operator, it basically sets each bit to 1 if both the bits are 1, which basically means that if both the bits are true, then the answer would be true as well. If one of them is false, then the answer would be still true if you're using the bitwise or operator. And let's say if we have one of the bit is 1 when one of the bit is 0, which means one of the bit is true and one of the bit is false, then and it will basically change the all the bits to 1 only. And similarly for not, basically inverts all the bits, which means if the answer is true, it will change it to false. If the answer is false, it will change it true. And then we have the zero fill left shift and signed right shift. So in the zero fill left shift, the bits are shift left by pushing zeros in from the right, and let the leftmost bits fall off. And for the signed right shift, the shift right is happening by pushing copies of the leftmost bits in from the left and let the rightmost bits fall off. Basically looks like something like this, the left shift and right shift. If I want to basically do the left shift on 10 by two places, the answer would be 40. And if I do the right shift, the answer would become 2. So now that we have also discussed the operators, and we have established how we work with variables and operators, let's move a little ahead and talk about various data types that we have in Python. All right, guys. So collections in Python basically are some of the data types that we're going to discuss. Before that, I'm just going to discuss integers and strings for a while. So integers are just numbers, guys. So any number or numerical value is considered as a number data type or numerical data type. It could be an integer, it could be a float value, it could be a boolean, or it could be a complex number as well. Strings are a data type in Python where we store the values with alphabetical, values, and we enclose them in single inverted commas or double inverted commas. And they're basically the same also. We do not have any distinction between a single inverted comma or a double inverted comma. And yes, I've shown you like how we can declare a variable, guys. So this is how I declare a variable. Let's say yes, so this variable is I can check the type of the variable. So this will show me that this is a string data type. And similarly, if I have another variable which has some integer value, I can check the type of the variable again, and it will show me that it's a integer variable. Right, so this is all about integer and strings. So the next data type that we have is a list in Python, which is basically declared in square brackets, mutable. So a collection in Python is basically, a container data type. Namely, we have list, sets, tuples, and dictionary, and they have different characteristics based on how we declare them and how we use them. So coming back to list again, it is mutable in nature, which means you can change them, unlike strings. So strings are immutable in nature, guys. So let's say if I have a name is equal to a scene. So if I want to access some values, I can use the indexing, guys. All right. So indexing is nothing but, the index values that we have over here. So I'll just explain what indexing in strings is. So basically, if I write name and in the square brackets, I've written 2 over here. So the index value is 2, which I want to access. And at index number 2, we have the third alphabet from the string. So which means is the indexing order is starting from 0 and going until the end of the string. So this is how we use strings. So if I want to reassign the value at index number 2, if I write instead of S, I want to write a capital S. So it says type error, which is saying that string object does not support item assignment. So basically it's immutable in nature, but in the case of list, I'll show you guys. So let's say if A is equal to a list, we just declare it in square brackets, and to access the values inside a list, we use indexing again, guys. So it can also store duplicate values as well. So let's say if I have 1, 2, 3, 4, and 5, and we'll add 1 again. So just to be sure that we have in duplicate values as well. So this is how a list is declared in Python, guys. And if I want to access, I can use indexing, and I can use slicing in the indexing as well. This is how slicing is done in indexing, negative indexing as well, which can be used to, get reverse of a list. So here what I've done is I've used the negative step and I've iterated from the back. So that is how you do it. So if I say write it from 4 and -1, we have an unexpected end of, right? This is a syntax error. So as you can see, guys, this is how it's done. All right, so from index number 4, we are going until the end of the list, but the step is a -1. So we are starting from here, 0, 1, 2, 3, 4. Starting from here, going in the opposite direction, because the step over here is negative step. That's why you're going in the opposite direction, and that's how we are getting the values. All right, so this is all about list, guys, and list also comes with a lot of methods that you can use. So basically, these are the methods that we can use for a list, which are reverse, remove, pop, insert, index, extend, count, clear, copy, etc. So if you want to know more about these methods, how we can use them, we have a full tutorial on list in Python that you can use. So I'll just show you how you can insert a value inside a list. So let's just check. So index number 0, we have added the value 1. So this is how you insert a value. And if I use the pop method, I am actually removing that particular value from the end of the list. All right, so this is all about list. Now coming back to dictionaries, guys. So let's say we take dictionary and we declare it in flower braces. And so we use the flower brackets here, and we have to use key value pairs. So let's say 1 is the key, this is value, 2 is the key, and we'll get another value. So these are two value pairs, key value pairs. And when I print my dictionary, I have somewhat like this. So if I access one, we can use the get method to get the values from the dictionary. So if I want to get the value which has the key 1, I can use the method get. Similarly, for all the keys, I can use this, or simply I can get the value using indexes as well. So in the indexes, instead of indexes, I'm just using the keys. And similarly, it also has a lot of methods that you can use, which is clear, copy, from keys, get, which are just shown you, items, keys, pop, and pop item. Right, so this is all about a dictionary that we're going to discuss, and after that I want to discuss a tuple, guys. So a tuple is ordered and immutable in nature, which means you also cannot change the value inside a tuple. And declare a tuple, again you use round brackets. So let's say I give it some values, right? So I use the indexing to access the values, and if I want to reassign some value, I have a type error which says tuple object does not support item assignment, which is same as a string, guys. So if you want to save something in a data type that you don't want to change in the future, you can use a tuple, guys, and it's ordered, so you can access the values again. And one more thing, so if I, let's say, give it some duplicate values, it is allowing the duplicate values as well. So this is all about tuples again, and it also comes with a few methods, that is count and index. So basically I can count the number of values that one has. So one has occurred thrice over here, and I can check for 2. Similarly, I can get the index value for, let's say, 1. I'm checking, it's giving the index value as 0, but it also has a value at index, that is second last index and the last index as well, but it will just fetch me the value which is which occurs the very first time for the method. So since it's in the beginning, it's giving me this value. Let's say if I write 2 over here, and if I check it for 2, I'm still going to get the value 1. So if I remove 2 from here, I'll get the value index as 5. So I hope you understand this. And after this, we have one more data type, that is a set data type, guys. So set is unordered, guys. So let's say if I have values 1, 2, 3, 4, 5, 6, and 7, print over here. So we have declared a set using the flower braces, and it is unordered and not indexed, so we cannot just access values from the set using index. All right, so but we can have all these methods that comes with the set data type, which is basically implement the set operations that you must have heard about or learned when you must have learned about when you were learning set theory. So it's basically it gets subset, superset, or okay. So we will have one more set, and now we will do a union, guys. So let's see if it works. All right, so let's change a few values here. 9 and 10 we'll add. So we have just done a set operation, do the union of two sets available to us. So that is how we can use the these data types, and these are the basic data types that we have in Python. Now after this, I want to talk about a few advanced data structures also that we have in Python. So these are general, Python's general purpose built-in container data types, and we all know Python always has something little extra to offer. It comes with a Python module named collections, and which has specialized data structures. So I'll mention a few data structures that we have in collections Python, but before that, we will have to import from collections, import all. Whenever you're using an external package or a module, this is how you import using an alias. You can use an asterisk to import everything from the package, or you basically import specific modules that you only want for your project. So I'm just going to import deck. Right, so we have deck, default dictionary, there is name tuple, we have chain map, we have counter, there is user dictionary, user list, and user string. So these are the collection advanced data structures. So I'll just briefly tell you about what exactly are these data types and what they do. So talking about name tuple, it returns tuple with a named entry, which means there will be a name assigned to each value in the tuple. It overcomes the problem of accessing the elements using the index values. And with name tuple, it becomes easier to access these values again, since you do not have to remember the index values to get a specific element. Now, see, basically what happened here is with data types, whatever problems that we had in the basic data types, advanced data structures are actually solving those problems. So if you take a look at the tuple, when I discussed, there was only two methods. One was to get the index of the number, and second was to count. Name tuple is basically assigning a name to a tuple so that you understand or you basically remember the value that you have to fetch from the tuple. Then again, we have deck, which is pronounced as dex, even if it's written as DEQUE, is basically an optimized list to perform insertion and deletion easily. So it comes with a bunch of methods that we can use, or we can also use deck to implement stacks and queues in Python, which is basically a way to implement a linked list in Python. So we'll be talking about that in a while. After that, we have chain map. So it is a dictionary like class which is able to make a single view of multiple mappings. So what happens here is it basically returns a list of several other dictionaries. Suppose you have two dictionaries with several key value pairs, and in this case, chain map will make a single list with both the dictionaries in it. So that is how you can use chain map. Then there is a counter, guys, which is basically a dictionary subclass, and we can use it to count hashable objects. Now you must be wondering what exactly are hashable objects. So hashable objects are nothing but in Python any immutable object, such as integer, it could be boolean string or tuple, is hashable. So basically whatever value that is immutable is actually hashable object. So counter is also basically a subclass which is used to count hashable objects. And then we have the order dictionary. So it is basically a dictionary subclass which remembers the order in which the entries were added. Basically, even if you change the value of the key, the position will not be changed because of the order in which it was inserted in the dictionary. So this is a very good advanced data structure, guys, which is an order dictionary. And basically you can remember, or it keeps track of which value came first, even if you have changed the value of the key. So that is one advantage over there. And then we have the default dictionary, guys. So which is basically a dictionary subclass that calls a factory function to supply missing values. So in general, it does not throw any errors when a missing key value is called in a dictionary. And after that, we have user dictionary, which is basically, a class that acts as a wrapper around dictionary objects. So the need for this class came from the necessity to subclass directly from a dictionary. And it becomes easier to work with this class as the underlying dictionary becomes an attribute. After that, we have user list. So this is basically acting like a wrapper around list objects and is a useful base class for other list like classes which can inherit from them and override the existing methods or even add a fewer ones as well. So now, even if I have discussed these advanced data structures, as a beginner, you should only stick to a few of them and basically focus on the inbuilt data structures. First of all, the basic ones like list, dictionary, and tuple, set, integers, strings. And I forgot to tell you about the range, right? So let's take a look at the implementation of dec as well, because it basically provides a lot of methods that can be used to implement linked list in Python. That's why I want to discuss this. All right, guys. So what we can do here is, so first of all, let's create a list, guys, and we'll call it as stack because we're going to implement stack over here. So 1, 2, 3, 4, and 5. And now if I have a deck over here, let's call it as stack again, and we are going to use deck. Inside this we'll pass stack, and now we have the deck. So what we have to do here is, now we'll use this stack, and let's see what methods do we have. So we have append left. There is extend left again that we do not really need, and we have pop and pop left. So these are two methods that we actually need, because let's say if I want to remove something from the beginning of the list, what I will do is I will write pop. So it is popping 5, which is at the end of the list. Now if I want to remove something from the beginning of the list, I can use pop left. And again, I can use append and append left. All right, so if I want to append, I will write 1, and my stack would look somewhat like this. All right, so it's actually adding a particular value at the end of the list. All right, so I'll just change it to 5 because we had 5 in the beginning. And then again, if I want to add something in the beginning, I will write append left and 1 over here. Now my stack becomes the same, and I can remove 1, let's say. Now the stack looks like this. I will remove 1 again. Now the stack looks like this. Stack dot append 5 and stack dot append left. All right, so we'll remove 5 again. Now, so how will we get the implementation of a stack or a queue, guys? So this is quite interesting. So for a stack, we have to follow the principle of last in, first out. So whichever value is inserted last in the list has to come out first. So that is implementation of a stack. And to implement a stack using deck, what we have to do is we have to remove the element that was entered last in the list. So let's say if we have an empty list, and if we use a loop, which we'll discuss later on in sessions, so we keep inserting the values inside the list or the deck, and after a point there will come a point where we have reached the end of the list and the last element has entered. So now comes the part where we have to get the last element out. So in this case, the first value is 1. So this will come out last from the deck, and this is the last element. So we have to use append in order to get the value, and we can put the whole logic inside a loop so that it goes forward, imitating the order of a stack. So it's a very simple example, guys. And after that, now comes the necessity to introduce functions to you guys, because the functions in a Python are a classic example of reusability, guys. How? To serve a wide range of applications from, let's say, GUI and mathematical computing to web development and testing, Python's interpreter already comes equipped with numerous functions that are always available for use, which we'll discuss in the Python standard library, guys. And you could also bring in other libraries or modules to your program, and that basically contain predefined functions, and they're ready to use. You will just really have to do is download required packages or according to their documentation, and freely avail its useful functionalities by importing them over to your code, like I have done over here, which I have imported collections module. From there I'm just using deck. It's basically a function from this module that I have imported. What I can do either way is define a function, guys. So how do you actually declare a function? So that is the important part here. How do we declare a function in Python? So you have to use keyword here, which is def, and after that you have to write the function name. So let's go with function name. So I'll pass. So this is my function, guys. I have created a function instead of pass, because we have not discussed the control statements. I will write return none. So this is how I have created a function, guys. So let's say if I want to print something, I want to print hello world. So now when I call my function, which is function name, I'm getting the value as hello world. And now let's give it a parameter as well. Okay. Now when I call it, I will have a type error which says function name is missing one required positional argument. So what we can do here is add a over here, and this is how I've just used a parameter. This is a very basic example of how I can use a function in Python. The advantage is simple, guys. So let's say I want to calculate something. All right, so I have two numbers which I will take the input from the user. I'll show you that as well. And I want to calculate the sum of those two numbers. Very simple example. Even though we have a predefined method for that, we will create a custom method for our own usage. So the first thing that I will do is I will use a return statement which will return the addition of these two parameters that we will get from the function call. All right, so now what I'll do here is I will get the input. So we'll use x and y. So input is one method that can be used to get the value from the user during runtime. We are taking int as input because we want summation, so we do not really want integer there, and that's why we are doing that. And after that we will call our function and pass x and y over here. So let's see what the output is. So the first number is 10, the second number I say is 20, and I have a type error, guys. It says function name takes one positional argument but two are given. So I think we have made a mistake, so it should be working now. So we have the summation of number using functions. So this is a very basic example how we can define functions and use functions. And there is one more function concept that I want to discuss, which is lambda function, guys. So we will take the keyword lambda and we will pass the arguments, and after that we will have the expression. All right, so let's call it as function. Now to call the function, I provide the values again 10 and 12 and gives me the sum, which is 22. So this is the example of using a lambda function, guys, where you can just simply define the expression and the parameters then and there inside the definition as well. All right, so this is all about functions that I wanted to discuss. Now we are going to talk about the conditional statements, guys. So when I talk about conditional statements, we really have if, else if, and else that I want to discuss. So these are the conditional statements, and apart from these we are going to discuss the control statements, which is break, continue, and pass. And now we are going to discuss the comparison operators as well. Okay, so let's say we have these two numbers x and y. So let's first of all check if x is greater than y. We will print greater. Alright, guys, so when I execute this, we are not getting any output. The condition is basically false here because x is not greater than y. So if x is less than y, we have this particular output, and let's go for this. So what we will do is we will check for another statement using else if. Now if first statement is false, it will check the other statement. So it will check if x is less than y. It will basically print smaller, and we have the output, guys. So now I want to change this to is equal to. So we have, again, we do not have any conditions. Now I will print smaller again. Everything else is failing. We are reaching the last statement, which is the penultimate statement, which is whatever that we give over there, it will print for us. So I want to talk about the control statements again. So let's say if x is equal to y, and we want to break, it's saying that syntax error, which is saying break outside loop. So basically what we have to do is we have to use break or the control statement inside a loop. So we'll do that while discussing loops, and let's just call it as equal. So to test it out, to check if your conditional statements are working or not, what you can do is get these values from the user. So A, we have 10, let's say. B, we have 15, and we have smaller. Okay, let's just put this inside one single block and run. So let's say 12 and 6, and again let's say 10 and 10 equal. So this is how we can use the conditional statements in Python. Now I want to talk about loops in Python, guys. Alright guys, so think of an analogy where your teacher has punished you and told you to write "I will not forget my assignment" 10,000 times. Okay, that's a bit harsh. She has told you to write it 10 times. So what you can do is, so using Python, what we can do is make this task very easy for us. So I'll just explain how we can use a for loop for the same task. So let's say we have to print "I will not forget my assignment." So we have to print this 10 times or 20 times or any number of times. So what I will do here is, I'll take a for loop for I in range 11, because we have to print it for 10 times. So as you can see, guys, this is a very practical implementation of how we can use a loop. So two things to actually see here, observe here: the number of iterations that we want, and what exactly is the output that we want from the loop. So this is a very simple example. So we have used for I in the range, which is basically the number of iterations we want. Right. So for the current iteration, it will start from the number 0. So range 0, then the range will become 2, the range will become 3, 4, 5, and when it reaches 11, the execution will stop. So this is how for loop works. We give it a statement, we give it an ending, already know the execution will end at this particular iteration, and we have the output. And in this particular section or the block, we can have any code that we want. We can have a function here, we can have a class, we can have any code that we want to iterate over and over again. So that is how loops in Python work. Now we have another kind of loop which says we have a statement, and as long as is it true, it will keep on going and going. So for the same task, what I can do here is get a count variable, and as soon as count is equal to 10 or 11, let's say, and we'll have count is equal to 1 or 0, and we will print "I will not forget my assignment." And after that, we have to increment the value, because that's how we will increment the value again. Right. So I actually forgot to mention here, the condition has to be true all the time. So as soon as it becomes greater than or equal to 11, it will stop the iteration. So we have our task performed here exactly as we wanted to. So these are the two loops that we have. So the only difference between for loop and a while loop is, in the while loop you have to give the statement, and the loop will run on until or unless the statement becomes false. So you have to keep in mind that you are actually incrementing the value, or you're providing some sort of closure to the loop, so that the condition will become false eventually. Otherwise the loop will run on forever. And for the for loop, we already know how many executions will happen. So that is the difference, the main difference between while and for loop. So now we'll talk about the iterators, guys. So a Python iterator is a container containing a countable number of values. And a value in a container can be traversed using iterators, which is particularly list, guys. And apart from traversal, iterators also gives access to data elements in a container, but does not itself perform iteration, which is not without some significant liberty taken with that concept or with trivial use of terminology. An iterator is almost similar to a database cursor in behavior. So let's see how a database, this actually works, the iterators. And after that, we will talk about Python iter tools, guys. So let's say we have a list, right? So it has some values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now iterable is exactly an object which one can iterate over. So right now, a list which we have declared over here is an iterable. An iterator will be an object which is used to iterate over the iterable object using iter and next method. Now to make this list iterator, what we have to do here is, okay, I'll write a is equal to iter a. Now this is an iterable object, guys. Now what I can do here is, using this iterable object, I can use the next method and get the value, right? So using this next method, we can get the values or iterate over this iterable object. So every time I execute this next, I'm getting the next value, and when I reach the end value of the iterator, it will stop the iteration, or it will throw an error because we have not specified the stop iteration over here. So it's, yes, the stop iteration is there. And so that is exactly how we use iterators in Python. Basically, we have iterables which we can convert to an iterable object using iter method over here, or we can use iter tools, which I will discuss now. So what exactly is Python iter tools? Iter tools is a module that has a lot of functions and tools that can be used to create iterators in Python. So there are a few methods that Iterators comes with, and let's just talk about how they work. So the tools or the methods that can be divided into subcategories. So there are infinite iterators, and then there are the iterators that will terminate on the shortest input sequence. There are combinatoric iterator as well. So let's just talk about the infinite iterators first. So we have three tools for infinite iterators using iteratools. So first of all, let's just import. We will import count. So count basically has two parameters, start and a step. And the iterator will return evenly spaced values starting from the start. So let's see how this works. Let's say a is equal to count. We have two parameters, which is start and a step. Let's say starting from 0, give it a step 10. All right. So now each time I use the next method, I'm getting the values. So basically what I'm doing is I am getting these, iterators from these methods. Basically, this is an iterable object which I can iterate over using next, or I can put it inside a for loop. Since it's an infinite iterator, if I do not give it stop iteration condition, it will just go on forever. And similarly, infinite iterator, we have count, we have cycle, and we have repeat. Cycle basically returns a copy of the elements from the iterable and takes only the iterable as the parameter. Then repeat basically returns the element again and again. So the repetitions are determined according to the parameter that decides the number of times the object will get repeated. And to check the exact syntax, we can go to Python iter tools, the official documentation. So here we have all these how you can use the infinite iterators, iterators terminating on the shortest input sequence. There is accumulate, chain dot from iterable, compress. So all these iterators, they have also given the examples. So you can use accumulate. So let's say you have iterable over here, it will give the values again like that. So this is how you can use the iter tools methods. And then again, we have combinatoric iterators, which will give the product, the permutations, combinations, and combination with replacements. So this is a very important, module that we have in Python, which is inbuilt, guys. It's basically giving us these iterable objects, which we can just use wherever we want. Wherever we want to iterate over an iterable, we can use these objects. This is why it is an important concept that I wanted to discuss. So as you move forward, once you learn how you can work with loops, and then moving forward, you will come across complex questions. And for the very similar reason, I discussed the advanced data structures also, because as a beginner, there are a few things that you will get spoon fed, and some things you will have to eventually discover. So I didn't want to keep you into dark, because advanced data structures are something that you will eventually use working the complex problems. So similarly for the iter tools also, you will have to use these iterators some way or the other in complex problems. That is why we're discussing this. And after that, we have generators in Python, guys, which is also a very interesting topic. So generators are basically functions that return traversable objects or items. All right, so how is it different from a iterator? We'll discuss that. So these functions do not produce all the items at once. Rather, they produce them one at a time and only when required. All right, so whenever the for statement is included to iterate over a set of items, a generator function is run. And generators have a number of advantages as well. So we'll discuss these advantages first. So without generators in Python, producing iterables is extremely difficult and lengthy. And generators are easy to implement as they automatically implement iter and next. So in order to create an iterator, we have to use iter and next. But using generators, we can just implement them automatically. And stop iteration also is implemented automatically, which we have to use otherwise. And memory is saved as the items are produced as when required. So whenever you're requiring that, then only the items are produced. So it's actually saving a lot of memory as well. And this fact becomes very important when you need to create a huge number of iterators. And this is also considered as the biggest advantage of generators. It can be used to produce an infinite number of items as well, and they can be used to pipeline a number of operations. So these are all the advantages of using generators. Now the question here is, what exactly is a generator? So we have talked a lot about generators. What are the advantages? We know that it's actually returning traversable objects or items. So generators in Python are created just like how you create normal functions using the definition, that def keyword. And the generator functions make use of the yield keyword instead of return. So that is the only difference between a normal function and a generator function. And this is done to notify the interpreter that this is an iterator. So when you're using yield, the interpreter already knows that this is an iterator. And not just this, generator functions are run when the next function is called and not by the name, as in case of the normal functions. So you can just call next and the generator function will run. So we'll take a look at, a little implementation of how generators works in Python. So let's take it up to Jupyter Notebook and we will see how generator works in Python, guys, how we define a generator function. So we are going to use the keyword definition. Let's call it as generator because this is going to be our generator function. And after this, let's take a number is equal to 1, or let's take it as 10. After this, I will yield this number a. So when I call next on this, I'm getting a type error, which is function object is not an iterator. So I have to create an object. So this is my object now, and if I write it like this, I'm getting as 10, and the iteration is stopping because this is not exactly an iterable. So let's take it in the range 10. So we'll have 1, next is 0 to 10. Okay, so we basically forgot to convert it into an iterable. Now it should work fine. So if we take one element, all right, so we'll define something so that we only get one value at a time, a of 0, and then a of 0 is equal to this. So let's call it as b, and now we'll yield b. Just defining the logic. All right, so instead of this, what we can do here is, let's just take a number first. All right, guys, so this is just to show you how you can define a generator function, and this is a very basic generator function that we can use. So right now we're already done with iterators and generators, and we're left with decorators. But before discussing decorators, let me just discuss a concept, which is class and objects. So as you already know, guys, if you are from a programming background, so a class is nothing but a collection of a lot of variables, objects, functions, basically a lot of things, and that you can wrap inside a class and use it for later, or you can inherit from those methods or something like that, and you have objects to take values from them. So now to fully understand this, let's consider an analogy. So let's say you have a class, and your class is basically your complete college. Your institution is the class, and you have different variables there. So for each branch of the university or the college is a member function. And whenever you want to call, let's say, School of Engineering or School of Architecture, you have separate member functions. And all of that is enclosed inside a class, which is the university. And inside those member functions, there are variables, which is basically the number of students and the details of those students. So what you can do here is create an object, and to pinpoint exactly to the particular student that you want from the School of Engineering, what you will do is you will call the method, the member function, which is containing the values of all the people from the School of Engineering branch, and then find the particular details using that particular member function without disrupting others. So this is how the analogy works, and this is a very basic example. Also, I'll just show you how you can create a class. Let's say we create a class like this, and we have a function. Let's call it as School of Engineering. So let's call it as SOE, and it has some values, and it returns name is equal to name, and we'll write branch is equal to this thing. All right, so we'll call it as engineering, and we will return name and branch. So let's see if it works. So now let's create an object. To create an object, what we have to do is We'll just create an object called uni. Now using this, we call the memo function, provide the name. Let's call it as this, and we are getting these values. So now what happened here is I had a class university. Using the parameter, I'm providing this name particularly, but with that name I can add values, guys. So let's say if name is equal to, write computer science engineering, else we will write branch is equal to, let's call it as mechanical. Just to show you guys, this is a simple example. So now let's say this is an example. So we have computer science engineering. Now let's say I write it as somewhat like this. Let's say I write Omkar. Okay, we have an unbound local variable branch reference before assignment. So I'll just remove this. I think this is the error, right? So now I think it's be fine. All right. So what I've done here is, even if I remove this now because I was making a syntax error, a slight syntax error, so I'm getting this value, guys. So this is how we can use classes and object easily in Python. And after this I want to discuss decorators in Python. And before that, this is just a very basic explanation of how classes and object is used. What I want you to do on your own is, after after you're familiar with classes and objects, I want you to do it as an assignment to look into how inheritance works, how the object oriented concepts work, and how you can implement multiple inheritance and all these concepts. So we already have tutorials on our YouTube channel that can help you, but as a beginner I want you to try it on your own to implement using basic implementation of all these concepts that I'm talking about. So moving on, let's talk about decorators. So decorators in Python are very powerful, which modify the behavior of a function without modifying it permanently, which means is it basically wraps another function, and since both the functions are callable, it returns a callable. So in hindsight, a decorator wraps a function and modifies its behavior. Let's take a look at the example to understand this better. As I've already told you, a decorator will wrap another function and modify its behavior. So we will understand this with a basic example, guys. So we'll take a function first of all, and using this function we are going to pass the function as the argument. And okay, let's call it as function1. This will be the argument that we are passing. Function as an argument, guys. You heard me correctly, guys. You can also pass a function as argument. Now we will have another wrapper function, and inside this we will have a statement. Let's call it as hello. And after this we have a function that we have passed as an argument. And after this, let's print something else, right? So we'll write welcome to Edureka, and we will return wrapper. So now we'll have another function, function2, which we will pass as argument in our function1. And let's just keep it simple, print learner here. Now we will call the function1. All right, so now we'll call the functions or make the function calls. So function2 is equal to, call the function1, pass function2 over there, and call function2 now. So as you can see, guys, we have basically used a decorator. So this is a simple implementation of how we can modify the behavior of the function. And instead of doing this, what we can do here is write this, and we will remove this. All right, guys, I think we're making a mistake here. So function has to be there, and now we're getting the same output, but instead of making that call over there, we're just writing it with an at symbol. And that's how we use the decorators in Python. And now we will move on to Python standard library, guys. So this is the official documentation of where you can find the Python standard library. But what exactly is there in the Python standard library is the built-in functions and the built-in types, or the built-in exceptions, all these values that we have. So we have date time, there is a calendar, collections. All right, so we basically use the collections module, which comes from the standard Python library. So it is a very important concept that we have in Python, where we can just learn about all these inbuilt data types first of all, or inbuilt functionalities that comes with it. There is Iterators, there is func tools as well, which is basically a higher order functions and operations on callable objects. So this is also one of the very important concepts that we have in Python also. So there is CSV, and all the file formats are there. So Python standard library plays a very important role when you're learning Python. And I would suggest you to explore all these values that we have, all these functionalities that we have in Python standard library. So we have built-in functions. So let's take a look at the built-in functions that we have. There is ABS, the all, ASCII, there is a list, all these constructors, checking the length, and in the documentation they've given how it works as well. So as a beginner, I would suggest you to check out the Python standard library. It will help broaden your perspective about what exactly is possible with Python. So that's why I wanted to discuss Python standard library, and not just the built-in functions. Let's take a look at built-in types as well. So there are truth value testing and comparisons and etc. These are something that if you read about them in documentation, you will understand. And there is text processing services as well, string, the regular expression, text wrap, Unicode data, and all these things. Read line is one of the things that we are going to use while doing file handling. Get to that. Now that we're done with the standard library also, let's talk about the exception handling, guys. So what exactly is exception handling? So in Python, the try and except block is used to catch and handle exceptions. Basically what happens is when you are executing a program, there are errors and there are exceptions. So exceptions usually happen, during runtime, and you have to take care of them unless repeat, or they will, cause execution problems. So Python basically executes a code considering the try statement as a normal part, whereas the except statement acts as the program's response to any exceptions that may occur. And exceptions are convenient for handling errors and special conditions in a program. So if you're working with a code that can produce an error, then you can use exception handling, and also you can raise an exception in your own program by the raise exception statement. And raising an exception breaks current code execution and returns the exception back until it is handled. So there are a few exception errors. So these are different types of errors, such as IO error, which is if the file cannot be opened, you will have an input-output error. When an unrequired key is pressed by the user, there is value error when the built-in function receives a wrong argument. There is end of file error, which is hit without reading any data. And there is import error if it is unable to find the module. So let's do one thing, guys. Okay, so let's say if we have not installed a module in Python, so we will basically have an import error, right? So I'm going to use, so let's do this cv2.read, and we have a name error which is saying cv2 is not defined. All right, so let's take a look at try print xyz and catch block, try and except print exception. All right, so now I will try to import something that I have not really installed here. So we'll do, all right, so we already have PyAudio. So we'll try to import something that we do not have. So let's do this, and it's calling the exception. So as long as whatever code that you have over here, okay, we'll remove the whole try block and except block. So we are getting the output as exception, which is in the except block, because it's not able to import PyDodge. We're basically getting an error. That's why it's going to the except block. Now that is how exception handling is done in Python, guys. So wherever you can find any errors in your program that you want to handle, you can just put it inside a try and except block, and whichever code that you want to execute will be executed in the try block. Or if at all you come across any exceptions or errors, it will be handled by the except block. So that is all about exception handling. Next up is multi-threading, guys. So a thread is basically an independent flow of execution. A single process can consist of multiple threads, and each thread in a program performs a particular task. For example, when you're playing a game of, let's say when you're playing FIFA on your PlayStation, and the game as a whole is a single process, but it consists of several threads responsible for playing the music. There'll be a thread for taking the input from the user. There'll be a thread running the opponent synchronously. There'll be a thread, and all these threads are separate and responsible for carrying out these different tasks in the same program at the same time. Every process has one thread that is always running. That will be the main thread, which will make sure that the game is running, of course. And this main thread actually creates the child thread objects, and these child thread object is also initiated by the main thread only. So when you open the game, which is the main thread, these all child threads are also initiated and they're running simultaneously. But there is a main thread that is making sure that each of these thread is running as well. And let's take a look at when we actually use multi-threading in Python before moving on with an example. So multi-threading is a very useful for saving time and improving performance, but it cannot be applied everywhere. And in the previous FIFA example as well, the music thread is independent of the thread that takes your input, and the thread that takes your input is independent of the thread that runs your opponent. So these are all independent threads, and they run independently because they're not interdependent. So therefore multi-threading can be used only when the dependency between individual threads does not exist. So how do we achieve multi-threading in Python? Multi-threading in Python can be achieved by importing the threading module first of all. So you have to import threading module. So let's see if we already have threading. So we're going to import everything from threading. Now the next thing that we have to do is we will perform multi-threading, which we can accomplish without creating a class as well. So we have created or imported everything from threading. So now we are going to print current thread dot name. So we'll get the name of the current thread, which is the main thread. And now after that, we will create a main thread function. Let's call it as function. And inside this, we will have all the child functions, right? So we'll have, let's say, this is a child thread. And let's call child is equal to thread. And we'll get target is equal to function. And yes, and we will start the thread. Now we will print current thread dot get name again. Let's see. Okay, function attribute has no name. Okay, so we are still getting main thread. Okay, let's see what we are doing wrong. Actually, we have to keep it outside the function, and let's print something here. All right, so in this output we have the current thread, which is main thread. After that, it creates a child thread and it runs, and whatever we can run it inside this thread basically. And after that we have the current thread again, which is the main thread. So this is how we implement or achieve multi-threading in Python. This is a very basic example how you can do it, and this is by not creating a class. So this is a very basic example. Also we have a tutorial on multi-threading that you can refer, where we have other implementation methods as well that you can follow. So what we can do here is we can do the multi-threading by extending the thread class as well. And after that we can do one thing also. We can do this without extending the thread class as well. Basically, advantages of using threading is it has a better utilization of resource, it simplifies the code, allows concurrent and parallel occurrence of various tasks, and reduces the time consumption or response time, thereby increasing the performance as well. So this is all about multi-threading in Python. Now let's talk about importance of file handling in Python. So the question must have stuck your head, isn't it? Why so buzz and stress about this simple thing? Well, for that, let's take an example. Suppose you want your Python script to fetch data from the internet and then process the data. Now, if the data is small, then the processing can be done every time you run the script. But in case of a humongous data, repetitive processing cannot be performed. Hence, the data process that needs to be stored. This is where the data storage or writing to a file comes in. And one thing to note while writing data to a file is that its consistency and integrity should be maintained. So that is why file handling it's a quite important concept in Python programming. And as a beginner, it's easy to learn this, mastering the basic concepts so that you'll be able to understand this in a better way and don't have to come back to it later on. So once you have stored your data on a file, most important thing is its retrieval also, because in computer it's stored as bits of ones and zeros, and if its retrieval is not done properly, then it becomes completely useless and data is said to be corrupted. So writing as well as reading is also important aspect of file handling in Python. And now we're going to learn about how we can open a file, or appending or writing to a file and closing a file. All right guys, so now what we'll do here is we will open a file using file handling operations, write something in a file, and then we'll try appending a few values there, and then we'll close the file. So I'm going to take this okay, so just create an object here. Let's call it new file. Using open, I will give the file name. Let's say this is my new file.txt. And after that, I have to give the mode here, which I am going to give it as X and T. All right. So we have created a new file. Now what will happen here is we will write something to the new file, and let's just write this is a new file. right? And now we will read from the file. All right, so we'll do one thing before we can read it again. Let's close it. And now we'll create another object, and we will call it as read file. And using this open again, we will read the new file. And now the mode will be RT. As you can see, guys, using this readline method, we have just read the file that we had just created. So let's close it. And after this, we will create another object, call it as write file is equal to open, and then open the new file again. And now we will write into this file. So we will write W. So if I want to write the complete file, I will use WT. And if I want to append something, I will use AT, right? Yes, now I will use, right guys? So we will write again. Okay, and now we will close the operation. Now again, we will use another object, and using this, we will read from the file, which is new file .txt, and we are going to read, right? So read new file dot. Now since there are too many lines there, we're gonna get all the lines, and so this is a new file, and I'm appending this in the file. Also, if I, instead of using AT over here, if I had written WT, this will be the new line rewriting the whole content of the file. So this is all about file operations, guys. A simple basic operation of how you can open a file, create a new file, read from the file, append new values, write new values there, and ultimately you can close the operation again. So we're good to go. Now we are reaching the end of the session, guys. So I'm just going to tell you about a couple of programs that you can write after mastering these concepts. So I would suggest you to check out our Python projects tutorial. We have uploaded 10 projects there, starting from the beginners perspective. There are intermediate projects as well and advanced projects as well, so you can check it out. Also, we have a Python programs blog, and there's a lot of content that you can find online on our YouTube channel. So I'll just show you two programs, guys. Palindrome checker, and the second program will be a simple basic guessing game. So in the first program, we're going to make a function, guys, right? So okay, this could be anything. And so first of all, what we'll do is there'll be a new number which is equal to number, and we reverse the whole thing, because since we can use indexing with strings as well, so it doesn't matter if it's a number or if it's a string, we can just change the values there. So I hope everybody knows what exactly is a palindrome. So palindrome is a number or a string which is same if we reverse it. I mean, the spelling would be same, like madam. If you reverse it, it will still be spelled like MADAM, right? So now what we want is we want certain conditions here. So if number is equal to new, we know that it's a palindrome, so we'll print palindrome. And else if number is not equal to new, we know that it's not a palindrome. And in any case, if we do not have any values, we'll print enter again, right? So now we call our function here, which is palindrome. Let's give it a palindrome. First of all, let's just check it's a palindrome, guys. So if I change it to, let's say, Edureka, not a palindrome. And now let's switch it to a number here. So int object is not subscriptable. So what we can do here is we can probably change it to a string, and let's see if it works. Yes, it's a palindrome. And let's check for another number. Oh no, it's not. Then again, let's try it for this number. It's a palindrome. So basically we have just made a function to check if a number is a palindrome or not. Similarly, you can do that for calculating the factorial of a number. There you will be making use of loops in Python and other concepts like conditional statements that we have used over here. Now the next program that I'm going to show you is the guessing game. So basically we are going to import random over here. All right, so okay, we'll just take a number which we are going to guess. So random dot random range, we'll take the range from 0 to 100. Let's take step 2. So we'll have only 50 values that we can calculate. Now we take a value from the user, right? So we take input and enter a number, all right? So basically what our aim here is, right, this is invalid syntax. Our aim here is whatever the random generator is generating over here, we have to guess that correctly. So whatever value that I enter over here, I have to check if that is equal to number or not. So what I'll do is, if number is equal to guess, we'll print you win, else we'll print keep trying. Okay, right, so it's saying keep trying because it's a number that we did not really guess correctly. So I'll put this over here. All right, so let's generate a number, new number again. Okay, we'll remove this. Now we run this. Now I'm entering a number. Let's say I enter 50. It says keep trying. And now let's get number also. So it's 70. So let's say if I enter 70 over here, it says you win. So now a game has to be, in a fun way. So we'll add condition here and we'll run a loop. So while we say, so we can give as many conditions here, like we can give condition until you guess the number. You can keep on going guessing, or you can do one thing. Or while count is less than, let's say 5 or less than 6, we will keep running this program, right guys? Yes. And after this we will do a count plus is equal to 1. So each time we go to the else block, the count value will be increasing. And let's give count a number here. Let's give it a 0. Now run it again. So we know that the number is 70 already. So we'll just check it for the program. So let's say we get 10. Okay, it says keep trying. We give it 20. It says keep trying. Let's give it 30. It says keep trying. 40. Keep trying. So we have 4 values. Now the count would have become 1, 2, 3, and this is 4. This is 5, and yes. So we have got out of the loop because the count value became 6. And if you give it the value that it needs, you win. So even if you win, the program still keeps executing the numbers, right? Again and again until the count reaches 6. It exactly does not have any other value, right? So we have made a mistake over here. So what we want to do here is, let's keep the count out of the if block, right? And after this, if we win, we want to give a break, right? So we'll run it again. Okay, we'll have to restart the kernel to bring it to life because we did not stop the program over there. So restarting the kernel now, right? So if you guys do not really know how Jupyter Notebook also works, so it's a part of Anaconda Python. So you can download Anaconda Python from the official website. And if you want any assistance there, we have an Anaconda tutorial as well, which you can follow. Right. So if we have 70, let's say, okay, the number is not defined. So we'll have over here. So our random number right now. All right. So we'll have to probably execute this as well. So random number is 12 now. So we want to check if we guess it correctly, is it okay? So we win and the execution stops. So this is how you create simple programs. And if you are looking for more such programs or projects to practice, we have tutorials on projects and the Python programs that you can follow, even starting from the basic ones and also for the intermediate ones. So I suggest you to check out our YouTube channel, guys. So we have come to the end of the session. If you have any questions, you can mention them in the comment section below and we'll be happy to get back to you as soon as possible. Also tell us in the comment section, guys, what topics do you want us to cover next so that we'll be able to help you better. And if you're looking for a certification program, the link is given in the description box below. And if you have come so far, don't forget to like, share and subscribe, and also press the bell icon to get the latest updates on Edureka. Thank you and see you in another session.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!